Here's some more problems from the related rates worksheet. And this is for number 9 through 12, and this is the airplane problem. These are all pretty similar. 9 through 12 would be like this problem. An airplane is flying at an altitude of 11 miles and passes directly over a radar station when the distance S between the station and the plane is 13 miles. Just at that moment, because that's changing, but at that moment when that distance is 13 miles, the station detects that the distance is increasing at 300 miles per hour. What is the speed of the plane at that moment? So first of all, you have to kind of get some data, get some mathematical terms. I did draw a sketch of what's going on over here. And you can see that this is the plane, and this is changing. This is its distance from the radar station, and this is changing. If the plane's over here, it's a little different. If the plane's over here, it's different, so you can see how this distance is changing. But it's constantly at 11 miles, so that's not changing, so that's constant. Now, so that's an idea of what's going on. So these are changing. That's why I wrote them as functions of time, but this is not. Okay, and what information do we have? Well, this is the altitude 11 miles, so I've got that already in my sketch over there. And when S, the distance between the station and the plane is 13 miles, so when S is actually 13 miles. Okay. Then the distance S is increasing, so that's ds dt. Equals 300 miles per hour. That'd be miles per hour. Okay. What is the speed of the plane at that moment? So that's as the x is changing, so that would be dx dt, so that's what we're looking for, dx dt. So first of all, you want to write down what you're looking for. Okay. And then figure out how we can get a relationship between these, what we call a mathematical model of this situation. And we have the good old Pythagorean theorem, which is an excellent way of translating a right triangle relationship into an algebraic relationship, because we know that a squared plus b squared equals c squared. So in this case, 11 squared plus x squared, you don't need this sub t there, equals s squared. So there's your relationship. Now we've got ds dt, and we want to find dx dt, so we have to get the dt's in there. So we'll take the derivative of everything. So we've got the derivative of 11 squared is just, that's a constant. So don't say it's 2 times 11. It's a constant. It's like 121. And that's just going to be 0. And the derivative of x squared is 2x times dx dt, because we're taking the derivative with respect to t, not x. All right? If it was dy dx, it would be 2x dx dx, or just 2x. But it's with respect to t, implicit. So we have to use basically the power rule and the chain rule. And this is going to be 2s, again, the power rule, and the chain rule, ds dt, the derivative of that. And we're trying to find dx dt, so we can divide both sides by 2x. So dx dt equals 2s divided by 2x times ds dt. So we'll just divide both sides by 2x. And 2 over 2 is 1, so we have dx dt equals s over x times ds dt. And then that's what we're looking for, so we just substitute our data in. And what's s? S is going to be 13. Up at the top, it says S is 13. And ds dt was 300 miles per hour. And x, what's x? So we don't know what x is. But this is a moment. This is a moment that this happens. The 11 is always the same, so we draw another triangle to find out what the x is. Because we know that these values are always in this Pythagorean relationship. In other words, 11 squared plus x squared equals s squared. So at the moment That S is 13. This is constantly 11. The altitude hasn't changed. What's the x going to be at that moment? So we still have that Pythagorean relationship. So we'll draw a right triangle over here. And you need to see these sketches in your work. And we know that this is always 11. And S is 13 at this moment. So what's x going to be? So we use our Pythagorean theorem, and we know that 11 squared plus x squared equals 13 squared. 11 squared is 121 plus x squared equals 13 squared is 169. And if I subtract 11, x squared equals, and if I subtract, if I take, that's 8, and that's 48. Double check it, 9, 6, okay. So that equals 48. So x equals the square root of 48. And that's the same thing as the square root of 16 times 3, which is 4 times the square root of 3. So that goes in here for x. Okay, so that's my dx dt. So, and let's see, we have 13. All right. And these are miles over miles, so I still have the miles per hour. And 4 goes into 375 times, so it's 13 times 75 all over the square root of 3. Half of 300 is 150, half that's 75, so 13 times 75 is that. And then if it's a non-calculated problem, you have to multiply that out. So I can do that over here. 75 times 13. 3 times 75 is 225. And 1 times 75 is 75. So that's 5, 7, 9. So that's 975, and we can leave it in radical form. So you can write it as 975 all over the square root of 3, and that would be miles per hour. You can rationalize if you want. But we should be okay. We can leave it like that also. Okay? And double check all your work, and that should be okay. So, but like I said, non-calculated problem, you could do the arithmetic. All right, you can always check it with your calculator, but make sure you can do your arithmetic, because you have to do some basic arithmetic always.